Welcome back. Let's do question 9.2. In the diagram, E, B, F, S, and P. E, B, F, S, and P are points on the circle centered at O. So we have the center O there. GB is a tangent to the circle at B. Then FE is produced. FE is produced to meet the tangent at G. OT is drawn such that T is the midpoint of EF. T is the midpoint of EF. Okay, so it means EF is the chord, and then this T is the midpoint. OT there is drawn from the center to the midpoint of EF. Okay, interesting. GO and BO are drawn. GO and BO are drawn. Where's GO? And BO are drawn. This is also BO. BS is drawn. This is BS is drawn through T. And then PS is parallel to GF. It's parallel to this one, to the GF. Before we look at the questions, I want us to discuss the information and the writer. Discuss the information in the writer first before you even go to the questions, and pick the key points from the information. In the diagram, E, B, F, S, and P are points on the circle centered at O. So we have center O here. So think of the center theorems also here. A line drawn from the center perpendicular to the chord will bisect the chord. A line from the center to the midpoint of the chord is perpendicular to the chord. An angle subtended by an arc at the center of a circle is 2 times the angle subtended by the same arc at the circumference. You think of all those center theorems. You may only use one or may not even use any of them, but just think about that. Then GP is a tangent. Think of the tangent theorems. Think of the tan chord theorem. Think of the tan radius or tan diameter theorem. And then think of the tangents from the same point theorem. Okay, you think about those theorems. FE is produced to meet the tangent at G. And then OT is drawn such that T is the midpoint of EF. You see, we're talking about the midpoint here. We have the center and the midpoint. Right? And then GO and BO are drawn. BS is drawn through T, and then PS is parallel to GF. Don't ignore this also. It's very, very important. Think of the geometry of parallel lines, corresponding angles, alternate angles, co-interior angles. We are told that GB is the tangent to a circle at B. OB is the radius. And then GB is the tangent. So which theorem do you think of here? Remember, the tangent to a circle is perpendicular to the radius or diameter of the circle at the point of contact. The tangent to a circle is perpendicular to the radius or diameter of the circle at the point of contact. So it means here GB is perpendicular to OB. And then GP is a tangent to the circle B. We've used that point. F is produced to meet the tangent at G. OT is drawn so that T is the midpoint of EF. So T is the midpoint. And then OT is drawn from the center of the circle to the midpoint of the chord. Right? Remember that the line drawn from the center of a circle to the midpoint of a chord is perpendicular to the chord. So this ETO is 90 degrees. This is also 90 degrees. Then GO and BO are drawn. BS is drawn through T. PS is parallel to GF. So we can see that this angle is corresponding to this angle. Okay, which is alternate to this angle. I think we've managed to get as much information as possible. Let's look at the questions now. Prove giving reasons that OTBG is a cyclic quad. OTBG is a cyclic quad. When I get such a question, I try to draw the cyclic quad, even though it's not going to be perfect, but let's try to join these points. OTBG. That's a cyclic quad. Not perfect, but I'll make sure all the points touch, all the 4 points touch the circumference of the circle, are on the circumference of the circle. Right, that's the cyclic quad there. We need to prove that OTBG is a cyclic quad. You have to think of this. Do we have an exterior angle of a cyclic quad? You check that. Do we have the opposite interior angles of cyclic quad that are supplementary? We have to check that. But if we check the cyclic quad, we don't have these two. There's another theorem that you have to remember, which is very, very important to prove that 4 points are concyclic. Concyclic means that the points are on the circumference of the circle. If a line segment joining 2 points subtends equal angles at 2 points on the same side of the line segment, then the 4 points are concyclic. If a line segment joining 2 points subtends equal angles at 2 points on the same side of the line segment, then the 4 points are concyclic. Right, if we check here, we have our 2 angles. This angle is 90 degrees, and then this angle also is 90 degrees on T here. The angle at B and then the angle at T, they are 90 degrees. They are subtended by which line segment? These two are subtended by the line segment GO. And then this line segment GO subtends the angle, the 90 degree angle here. It also subtends the 90 degree angle here. So we have these 4 points. 1, 2, 3, 4. If a line segment joining 2 points subtends equal angles at 2 points on the same side of the line segment, then the 4 points are concyclic. So it means OTBG are concyclic. Therefore, OTBG is a cyclic quad. Okay, let's write that. We said OTG is equal to 90 degrees. And then line from, that's the reason, line from center to midpoint of chord. Right, and then we said OBG is equal to 90 degrees. This is OBG, this one. This was angle OTG, then this one OBG. Tangent perpendicular to radius. Okay, and then OTG is equal to OBG, and they're both equal to 90 degrees. Therefore, OTBG is a cyclic quad. And then the reason, you can say line subtends equal angles. The line segment GO subtends equal angles on the same segment. Okay, and then or you can write this as a converse angles in the same segment. That's another reason you can use. We managed to prove that OTBG is a cyclic quad. Let's do 922. We need to prove that GOB is equal to angle S. GOB, where's GOB? We want to prove that this angle is equal to this angle. We discussed this. We said this angle S is equal to angle BTG. This one is equal to this one because of what? Because they are corresponding angles. Okay. And then now remember also that we have proved that OTBG is a cyclic quad. So it means this angle BT, this is T. Let me just write it. It means angle BTG is equal to angle BOG, because they are subtended by the same chord, GB. They are subtended by GB. Angle BTG is equal to angle BOG, and angle S is equal to angle BTG. Right, let's just write that. Maybe it will make sense if you write it down. Right, angle S is equal to angle BTG. Right, why? Corresponding angles. Since GF is parallel to PS. Okay? And then we said also angle GOB is equal to angle BTG. Their angles in the same segment. They are subtended by GB. We proved that this is a cyclic quad. OTBG is a cyclic quad. So we can say GOB is equal to BTG, since these are angles in the same segment. Alright, from here we see that angle BTG is equal to angle S, and then angle BTG is equal to angle GOB. So what conclusion can we make from this? We can conclude and say, therefore, angle GOB is equal to angle S. Okay, since both these two are equal to angle BTG. So therefore, angle GOB is equal to angle S.